Hello there, these are your examples for lesson 4.7. We're going to be starting on page 328. If you have not read through examples 1 and 2 on this page, go ahead and do that before you watch these examples. My first example is asking us right here. It's on page 328 at the bottom. It says, determine whether each table represents a linear or non-linear function. Explain. We should be used to linear, but non-linear may be a new word that we're not so used to. So I'm going to look at A first. A has a table, and if I want to figure out if it's linear or not, the easiest way is to find the constant rate of change or the slope. And I do that by looking at my table, and I think, how do I get from 0 to 5? I'm doing plus 5. From 5 to 10 is also plus 5. From 10 to 15 is plus 5. So this whole top is the same. It's all constant. It's all adding 5 each time they go up. Now, at the bottom here, I have 20 to 16. This time we're actually going down, so I'm going minus 4. And then 16 to 12, I'm also subtracting 4. And then 12 to 8, I am also subtracting 4 here. So all of the bottom is also the same. So if I were to explain if this is linear or not, which we do need to do because it says to actually explain it, I would say, yes, this is linear because x increases by 5 the whole time, and y decreases, if I could spell it correctly, it decreases by 4 the whole by 4 the whole time. Remember, we're trying to look and see if it's constant, if it's the same, and when it is constant, that's how we know it's linear. All right, now let's look at B. And B is another table. Let's look at x's first. From 0 to 2 is plus 2. From 2 to 4, plus 2. 4 to 6 is plus 2. So I know that at least the x's are the same. Now if I go to my y, bottom part of my table, I go 0 to 2. That's plus 2. 2 to 8 is plus 6. And then 8 to 18 is plus 10. So as you can see on the y values, these all change different values. So we should be able to tell, no, this is not linear because the y values are not consistent, meaning they are not the same. They change every time. Alright, now we are on page 329, and this is kind of right in the middle. Make sure you read example 3. And this question says, tickets to the school dance cost $5 per student. Are the ticket sales a linear function of the number of tickets sold? Explain. So we are trying to figure out, is this linear, yes or no? And how do we find if it's linear? We really just need to find the constant rate or the slope. And I do that with my swoops here. So if I look at the top, number of tickets sold, which is my x value, it goes up to 1 to 2 to 3. So on the top, they're adding 1 the whole time. On the bottom, I go 5, 10, 15. That's pretty consistent. The entire time they're adding 5 each time. So I will be able to explain, yes, this is linear because x and y are both increasing consistently, which means that they are both going up by the same number each time. The top is going up by 1 and the bottom's going up by 5. So that makes it consistent. It's the same. Our rate of change is not changing like that. All right, now make sure when you get to page 330 that you've at least read through example 4, and that's on page 329. And try it yourself is on page 330. Now it says a square has a side length of s inches. The perimeter of the square is a function of the side length. Does this situation represent a linear or non-linear function? So one thing that we might want to think about with a square is what it looks like. Let me see if I can get a nice square in here. There we go. So if you get a kind of word problem like this, I think one of the easiest thing that's going to help us is to make a table. I have my x values and my y values. So I need to think, what am I inputting and what am I getting out of it? So my input really is going to be the side length, or S. We could also label this S. And then my y is going to be the perimeter. Perimeter, P. Okay, so let's say our square here has a side length of 1. So I'd put a 1 in my x side of my table. So if this is a 1, then this is 1, 1, and 1. So the entire perimeter is going to be 4. Now let's think about, okay, what if I have a side length of 2? There's 2, 2, 2, 2. You could write all these out, or you just think, okay, what is 2 times 4? It'll give me 8. And let's do one more for good measure, and I'm going to make it a 3 this time. So if I have a 3 on all sides, 3, 3, 3, and 3, well, I can take 3 plus 3 4 times, or I can just do 3 times 4, which will give me 12. So if you haven't figured it out by now, let's look at our table, and we can use our swoops to find the rate of change and see if it's consistent. So on my x side, they're adding 1 each time. And on my y side, I'm going from 4 to 8 to 12. From 4 to 8 is plus 4. And from 8 to 12 is plus 4. So if I were to ask you for the slope of this, or the constant rate of change, you could tell me that it is 4 over 1 for the entire thing. So over here on the side, we need to explain that, yes, this is linear because the rate of change is the same throughout. So if you ever get stuck on a problem, I think that making a table usually is the best bet.